Hi folks, Mr. Long here. This is a screencast on completing the square, which is really about representing quadratics in vertex form. So what we're going to do in this section is you're going to start with quadratics. They're in standard form like this, x squared plus 6x minus 16, and you're going to use completing the square to represent it in vertex form. And if you remember from earlier, it's pretty easy to tell the vertex here. Because the whole idea is that this graph, is opening up, it's smiling because there's a positive out front. If there's no sign showing, it's positive. So then the whole idea is, what makes that bracket a 0? Well, the only number that can make that parenthesis 0 is -3. So when x equals -3, you've got the vertex. And then what's the y value? Well, if this happens to be -3, this whole thing is worth 0, and 0 minus 25 is -25. So the vertex would be at -3, -25. I'm also going to go through how to get the x-intercepts in a couple of different ways as well. Okay, so that's the process we're going to go through today, is completing the square. You'll notice that these are all simple ones with a equal to 1, and that's what we're going to focus on, because I want you to get a few concepts down. So let's try some examples. Oh, by the way, so these are the 5 questions you're going to need to do after you watch the screencast. So let's do this question here. Prove by completing the square that x squared plus 10x is x plus 5 quantity squared minus 25, and that the zeros are 0 and -10. Okay, so let's take a look at this. So I've got this right here, x squared plus 10x, and I need to complete a square. So I'm just off to the side, I'm going to draw my little square here, and let's see, I'm going to complete the square, and I'm going to have an x squared here, and I know if it's a perfect square, I've got to split that 10x in 2. So I'm going to have 5x here and 5x here. That means that, what's the width of this from here to here? Well, it's got to be x. The width of this has to be x, because x by x makes x squared. Then this has to be plus 5 if it's a square, and this has to be plus 5 because it has to be the same dimension. And then I've got, well, what's 5 times 5? 5 times 5 is 25, and now I've got a complete square. Now the only problem here is that if you look at this, this is the complete square. The complete square's got this 25 in it. Well, we don't have 25 here. We do not have 25. So what do I need to do then? Well, to complete my square, I've got to add 25. Okay, so here's what we're going to do. So I'm going to start with y equals x squared plus 10x. And I know to complete my square, I've got to add 25. But you can't just add 25 onto one side, you have to add 25 onto both sides. So let's add 25 to both sides, and that makes for a complete square. So I've got y plus 25 equals x squared plus 10x, 10x plus 25. So now I've got a complete square, right? Take a look, x squared plus 10x plus 25. So the right side is a complete square. Well, how do I represent that? I represent the right side as x plus 5 quantity squared, right? X plus 5 by x plus 5, length by width. And that incorporates all of those terms are inside that square. So I've got y plus 25 equals that. Well, I don't usually write my equation as y plus 25, as I've got there, so now I need to subtract 25 on both sides. So now I end up with y equals x plus 5 quantity squared minus 25. Alright, so that's the process for completing the square. Remember that in these screencasts, at any time, pause it, go back, take a look at what I've done. It's really important that you do that. To make sense of it. So let's look at the next page and get the x-intercepts. So here's what we're going to do. And of course there's easier ways to do it. Or there's many rather ways to do this. So we're going to get our zeros. And we have x squared plus 10x is one equation. Set that equal to 0. Well, for this one I can just common factor x plus 10 equals 0. So that gives me x equals 0 and x equals -10. Okay, that's one way of doing it. but we also have to be able to do it when it's in the vertex form. So if I have x plus 5 squared minus 25 equals 0. Because remember that this is an equivalent representation to this. Okay, so you need to be able to solve for the zeros of this or this. Now, what's interesting about this is this one here is actually, if you notice, there's a difference sign. Is 25 a square? Yes, it's 5 by 5. Is x plus 5 a square? Yep. It's x plus 5 by x plus 5. So you've got a difference of squares. Okay, so what I'm going to do, I'm just going to color this in here in red. X plus 5. So in this case I've got a equals x plus 5, and over here b equals 5, because the square of 25 is 5. And I know my formula is a squared minus b squared is a minus b times by, whoops, running out of space, a plus b. Okay, so let's do that. A minus b, a plus b. So that's going to equal. So the a part, I'll write in red, is x plus 5. And then the b part, I have to minus 5. Then in the second set of brackets, it's again the a part right here, which is x plus 5. And then I have, and the formula is plus b, so plus 5 again. So what does that equal? Well, x plus 5 minus 5 is gone. So that's just x multiplied by x plus 10. Take a look at that, would you folks? If you were to compare that, x times x plus 10, x times x plus 10. Okay, it's just, that's a difference of squares. We just don't generally treat that as a difference of squares. So let's one more page, and let's try to also solve it in a vertex form this way. X plus 5 squared minus 25 equals 0. This is the third way. So again, the first way was just to factor the standard form. The second way is to do a difference of squares on the vertex form. The third way is to do what's called inverse operations. So the way we do inverse operations is we do the opposite of bedmass. So what we start with if I had a number here, what would I do? Well, the first thing I'd have to do is add 5. So I'm going to write these in opposite, in the regular operation, and then you'll see what I do in a minute. So I would start, normally, if I had a value for x, I'd add 5. The second thing I would do is square it, right? Because I do in the brackets first, which is plus 5. And then the second thing I would do is square. And then the last thing I would do, if I had a number for x, would be to minus 25. Why did I do that upside down? Well, because I need to do the inverse of that. So this right here, folks, represents the regular order, bedmass. So I would start in the brackets. The brackets say to add 5. The second thing I would do is to square. The last thing I would do is minus 25. So now I need to look at, well, what are the inverse of each of those? Plus 25, square root, minus 5. And those are the inverse operations. Opposite order, opposite operation. So that's why I switched the order, right? So I would start by adding 5, squaring, and minusing 25 normally. Like this would be first, second, and third. But what I need to do is switch the order and switch the operation. So here we go. Let's do this. So the first thing I needed to do is to add 25. Well, that would get rid of that. So I'd have x plus 5 squared would equal 25. The next thing I would do is to square root. So we know that I'm going to get x plus 5, which is going to get rid of that root sign, and then it's going to be plus and minus 5. The last thing I want to do on both sides is to minus 5, which gets rid of that plus 5 there. So x is going to equal plus and minus 5 minus 5. So what does that give us for our two answers? Well, x is going to be equal to 5 minus 5, or x is going to equal negative 5 minus 5, x equals negative 10. So we get the same answers all three ways. So again, there are three ways to solve this equation. Start with the standard form and factor, or potentially I would also have to do a quadratic formula if it wasn't factorable. Okay, so standard form, you solve it. And then what's new is the inverse operations, what's new is the vertex form solving. So you solve by vertex form. How do you do that? You do the inverse operations, or you complete the square. Okay, and those are the two other methods we did. Okay, I'm quickly going to, and I know this is a long video, but I'm quickly going to do another completing the square example. Let me apologize. Let's go back to this. I had negative x squared. Probably want to do here is, oh, by the way, I want to, so I rewrite this with y equals negative x squared minus 6x minus 14. When I'm completing the square, I want to get rid of all the constants on the right side. So what I'm going to start by doing is adding 14 to both sides. Y plus 14 equals negative x squared minus 6x. So what I want to do is factor out a leading negative, which I need to do. So let's factor out a leading negative, because that's negative x squared. So I have negative bracket x squared plus 6x is y plus 14. But that's a very hard square to complete, so I divide both sides by negative 1. But if you look at that, that just gets rid of that sign, right? So I'm going to have y plus 14 divided by negative 1 equals x squared plus 6x. That's a tricky one, so I'm going to let you think about that for a second. You may want to rewind it. So what I did is I factored out a leading negative, introduced brackets, and then I divided both sides by negative 1 to make the right side much easier to work with. And I think you know how to complete this square. This is a pretty easy square to complete. I've got an x squared there, a 3x there, a 3x there, because I always have to have half, right? Half of 6x. Well, what completes that square? 9, 3 by 3. So I have x plus 3 by x plus 3 in my square. So now I've got to add 9. Well, I can't add 9 to one side. I have to add 9 to both sides. So let's look at it over here. So we've got y sorry folks, I've got y plus 14 divided by negative 1 is x squared plus 6x. And I need to finish completing the square. So how do we go about doing this? Well, we know over here, as we said before, we've got to add 9 to complete that square. So we've got y plus 14 divided by negative 1 equals, oops, I need to add 9 to both sides. So let's get rid of that. So I'm going to add 9 here, and then on the right side I also add 9. Right, and that's from before. This plus 9 completes the square. But I can't add 9 to one side, I have to add it to both sides. And now I know I can represent this in perfect square form. It's x plus 3 by x plus 3. So I've got y plus 14 divided by negative 1 equals, or plus that 9, whoops, equals x plus 3 squared. And now I need to undo these operations. Yeah, I need to undo these operations. And so here's what we do is this. I'm just going to take that, whoops, and lift that up a bit so I get some more room to write on this. So again, this is a plus 9 here. So what I'm going to have to do now is actually to minus 9 off both sides to get rid of that. So I'm going to have y plus 14 divided by negative 1 equals x plus 3 squared minus 9. And now I need to multiply by negative 1. So we're going to times by negative 1. How do we do that? We just do y plus 14 equals negative 1 bracket x plus 3 squared, but now it's going to be plus 9. Right, so I multiply everything by negative 1. And then in my last step, I need to minus 14 from both sides. So I end up with y equals, that gets rid of that plus 14, negative 1 bracket x plus 3 squared, and then 9 minus 14 is negative 5. And there, folks, is the vertex form for this representation. Y equals negative 1 bracket x plus 3 squared minus 5. So the question is then, what does this graph look like? Well, this graph, we know it's frowning because of that negative 1 there. We know it's frowning. And we know that the y value of the vertex is at negative 5, and the x value of the vertex is at negative 3. So if we were to do a rough sketch of this, it would be at negative 3, and it would be down 5. So it would open like this. Now, when we look at that, there's no x-intercepts, of course, because the sign on here is the same as the sign on here. So if the y value of the vertex is negative and the a value out front here is negative, there are no x-intercepts, no zeros. So there's no other work we can do. Alright, folks, so that is a very long screencast that goes through completing the square and solving for x-intercepts in vertex form.